Hello students, good morning. In previous class we have discussed electric charges, properties of electric charges and the methods of charging. We have discussed that there are three methods of charging: charging by friction, charging by induction and charging by conduction. And we have also discussed different properties of electric charge such as charges are of two types: positive charges, negative charges, conservation of charge, quantization of charge, additive nature of charge. We have discussed all these topics. Today I am going to discuss very important topic of this unit, that is Coulomb's law. Coulomb's law. Coulomb's law. Coulomb's law is the law which governs the force or interaction acting between two charged particles. Let us suppose there are two charged particles, one is Q1 and other is Q2. They are separated by distance r. Q1 and Q2 are separated by distance r. There are two charges, one is Q1, other is Q2, and they are separated by distance r. Then according to Coulomb's law, the magnitude of electrostatic interaction between these two charges is directly proportional to product of magnitude of the charges, and inversely proportional to the square of distance between the center of mass of the charges. I am repeating again, square of distance between the center of mass of the charges. That is, here magnitude of electrostatic interaction that we can represent by F, that is directly proportional to product of magnitude of the charges and inversely proportional to the square of distance between the center of mass of the charges. If we combine these two, we can write F directly proportional to Q1 Q2 by R square, and then applies F equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square R cap, and here we have to write one vector sign. This is Coulomb's law. Magnitude of electrostatic force or electrostatic interaction between these two charges is directly proportional to product of magnitude of the charges and inversely proportional to the square of distance between the center of mass of the charges. Since here we have considered only the point charges, therefore need not to consider or center of mass and the center of the charges are exactly equal. But if the charges are large, or if you can say the shape of charge is large, then the concept of center of mass becomes very significant. So here it is, F directly proportional to Q1 Q2 by R square, inversely proportional to R square. Therefore Q1 Q2 by R square. Therefore F equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square. And this we can also write K Q1 Q2 by R square RK. Here epsilon naught is known as electrical permittivity of free space. Here epsilon naught is known as electrical permittivity of free space or vacuum. the value of epsilon naught is 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square. Here it is epsilon naught. This is epsilon naught. If we take epsilon naught in this side, then F will become here. Therefore, Q1, Q2, it means Coulomb square divided by meter square in Newton. 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square. This is the value for vacuum, or we can say free space. And if we put the value of 4 pi epsilon naught and solid, then we get 9 into 10 to the power 9 Newton meter square per Coulomb square. It means for vacuum, instead of writing 1 upon 4 pi epsilon naught, we can also use this K having value 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is Coulomb's law. F equals to K Q1 Q2 by R square R. We can also write Coulomb's law like this. Let us suppose there are two charges Q1, Q2, and let us suppose both the charges are positive. Then Q1 will apply force on Q2 in this direction. Q1 will apply force on Q2 or electrostatic interaction on Q2 in this direction. And let us suppose this force I am denoting by F21. F21 means force on Q2 due to Q1. F on Q2 due to Q1. So F21. Force on Q2 due to Q1 is denoted by F21. Then F21 can be written as 1 upon 4 pi epsilon naught Q1 Q2 divided by. Now the distance between them, or the displacement vector between them, we can denote as R12. Position vector directed from 1 to 2. So here we can denote it as R12. Therefore we can say R12 square, and here R12 k. F21. Again you have to understand, F21 means force on charge Q2 due to Q1. But it is directed along the line joining Q1 to Q2. Therefore we have represented it by R12. Therefore F21 can be written as 1 upon 4 pi epsilon naught Q1 Q2 by R12 square R12 k. Similarly we can write F12. What is F12? Force on charge Q1 due to Q2. We can denote it as F12. Force on Q1 due to Q2, it will be in this direction. We are denoting it by F12. So F12 can be written as 1 upon 4 pi epsilon naught Q1 Q2 divided by. Now the position vector along this direction. This is the position vector along this direction, that is R12. And now position vector along this direction can be written as R21. Therefore we will write R21 whole square and R21 k. So this is the force on 2 due to 1. This is force on 1 due to 2. But both the forces are equal in magnitude. It means whenever we have to calculate electrostatic interaction between these two charges, then the value of electrostatic interaction on both the charges will be equal. So here we can say F12 equals to F21 magnitude. It means if Q1 apply a force of Q2 as 4 Newton, then Q2 will also apply a force of 4 Newton on Q1. But the directions will be different, but magnitude is same. It means by using Coulomb's law we can find out electrostatic interaction or magnitude of electrostatic interaction between two charges. Now here we have considered that both the charges are placed in vacuum or in free space, but if both the charges are placed in any medium, then electrostatic interaction or magnitude of electrostatic interaction or magnitude of electrostatic force will be different. Here we can differentiate Coulomb's law from universal law of gravitation, or here we can separate electrostatic force from gravitational force. In gravitational force there is no effect of medium, but electrostatic force or electrostatic interaction depends on medium. So we can write F medium. F medium will be written as 1 upon 4 pi epsilon m. Here we have to change. In vacuum we have to write epsilon naught. Here we have to write epsilon m, where what is epsilon m? Electrical permittivity of medium. Epsilon m is electrical permittivity of medium. That is epsilon m. I am writing in short, electrical permittivity of medium. Epsilon naught, electrical permittivity of free space or vacuum. Epsilon m, electrical permittivity of medium. Epsilon naught, electrical permittivity of free space or vacuum. And the third parameter we can use epsilon r. That is relative electrical permittivity of medium, or which can also be defined as dielectric constant of medium. So here we have introduced three parameters. One is epsilon m, electrical permittivity of medium. Epsilon naught, electrical permittivity of free space or vacuum. Epsilon r, relative electrical permittivity of medium or dielectric constant of medium. Now in this medium we can write F medium equals to 1 upon 4 pi epsilon m q1 q2 by r square r. This is the force in medium, electrostatic force in medium. And just before that we have discussed electrostatic force in vacuum, 1 upon 4 pi epsilon naught q1 q2 by r square r. So this is the formula for electrostatic interaction or electrostatic force between two charges whenever they are placed in medium. In medium we have to use epsilon m. Now by using these two concepts, one is force in medium, other is force in vacuum, we can also define relative electrical permittivity or dielectric constant of medium. Now I think it is clear. Dielectric constant of a medium. Dielectric constant of a medium, and it is denoted by epsilon r. Dielectric constant of a medium, or we can say relative electrical permittivity of medium, that is epsilon r, and it is defined as the ratio of electrostatic force between two charges placed at certain distance apart in vacuum. Electrostatic force between two charges placed at certain distance apart in vacuum to the electrostatic force between same charges placed at same distance in a given medium. It means here it is medium. Epsilon r or dielectric constant can be defined as the ratio of electrostatic force between two charges in vacuum to the electrostatic force between same charges placed at same distance in a given medium. And just before we have written the formula of these two, it can be written as 1 upon 4 pi epsilon naught q1 q2 by r square divided by 1 upon 4 pi epsilon m q1 q2 by r square. And finally we get epsilon m by epsilon naught. This is the value of dielectric constant. Epsilon r equals to epsilon m by epsilon naught, or we can also write epsilon m equals to epsilon naught epsilon r. Or from this relation we can also find F medium, electrostatic force between two charges in medium will be F vacuum divided by dielectric constant. And dielectric constant for different medium is greater than 1. That's why F medium is always less than F vacuum. F medium is always less than F vacuum since epsilon r is greater than 1. Epsilon r is greater than 1. The value of epsilon r will be different for different medium. For example, for paper or mica, its value is from 4 to 6. For water, the dielectric constant is 80. For air, the dielectric constant 1.00 something. It means the value of epsilon r is greater than 1, and therefore F medium will be always less than F vacuum. Hence, electrostatic force between two charges at certain distance will be maximum in vacuum, and in other medium its value will be less than vacuum. So this is the topic related to dielectric constant of a medium. Now we are discussing principle of superposition. Principle of superposition. This topic we also know from class 11. Class 11 में wave topic में हमने पढ़ा होगा principle of superposition for 2, 3 or more waves. Similarly, here we can also use principle of superposition. This superposition principle, or according to principle of superposition, if a charge is under the influence of many charges, if there are many charges, for example, a charge q naught is in the presence of many charges. Let us suppose first charge is q1, second charge is q2, third charge is q3, and fourth charge is q4. A charge is under the influence of four charges q1, q2, q3 and q4. Then definitely these four charges will apply force on q naught, but the forces will be different in magnitude and different in direction. Therefore, if we have to find out total force on this charge, then according to principle of superposition, net force on this charge will be the vector sum of all the forces. This is principle of superposition. If there are many charges, then net force will be the vector addition of all the forces, or vector sum of all the forces. Therefore, I can write F01. F0 means electrostatic force on a charge Q0 due to Q1. It can also be written as F02. What is meant by F02? Electrostatic force between Q0 and Q2, or we can say electrostatic force acting on Q0 due to Q2. That is F02. We can also write it as F03 due to this Q3, and finally we can write F04. And now by using the concept of vector addition, we can find the total force on the charge. And this concept will be very clear. Just after this I am going to discuss different numericals, and by using numerical this topic will be very clear that how we have to use vector addition whenever we have to find out net forces due to many charges. Many charges means if there are only two charges, then force is only one, but if there are more than two charges, then we have to use the concept of vector addition. And that concept will be very clear. Just after it I am going to discuss numerical, and then in numerical this principle of superposition will be very clear to you. So it means according to principle of superposition, net force on a charged particle is vector sum of all the forces. So this is principle of superposition. It means up to this topic we have discussed. I am coming to numerical based on Coulomb's law. We have discussed Coulomb's law between two charges, electrostatic force of interaction, that is Q1 Q2 by R square. But one point we should keep in mind very clearly, what is R, that I have already discussed. R means distance between center of mass of the charges. R is the distance between center of mass of the charges, and Q1 Q2 are the magnitude of charges, and we have to also keep in mind very clearly the direction of electrostatic interaction. That is very important. So this is what about Coulomb's law. Now I am considering different numericals based on Coulomb's law. Question number 1. There are two charges. One is Q and other is also Q. It means two identical charges, two identical point charges. Here I am using the word point charges. Two identical point charges Q and Q are placed at d distance apart. They are placed at d distance apart. I think question is very clear. There are two charges, one is Q, other is also Q, and both are identical. It means they are having same side. Both the charges are identical and they are placed at distance d. Question is that what will be new force? It means let us suppose initial force is F, that is given in the question. It means question is that there are two point charges, identical point charges placed at distance d apart, and electrostatic force of interaction between them is F, or we can say the magnitude of force acting between these two charges is F. What will be new force if magnitude of both charges is doubled and distance between them is halved? What will be the new force if magnitude of both the charges is doubled and distance between them is halved? This is our question. Now we are solving this question. Very easy question, very important question. Initially we can write F equals to KQQ by D square. It is given that both the charges are placed in vacuum. Initially the force is KQQ by D square. Now according to the question, we have to find out a new force. It means we can represent it as by F dash. It means new force, that is equals to KQ, first charge. According to question, the magnitude of both the charges is double. It means here it is 2Q. Second charge is also 2Q. And distance between them is halved. It means D by 2 whole square. And that will become 16 times of KQQ by D square. It means it becomes 16 times of F. It means the force becomes 16 times of the initial force. So this is the conceptual question related to Coulomb's law. It means magnitude of charges are doubled, therefore we get a factor of 2 into, that is 4, and distance between them is halved, therefore it becomes D by 2, and finally we can say 69. In such type of questions, generally it is asked that what is the percentage change. In different type of questions or in such type of questions, it is generally asked that what is percentage change in the force. So if we have to find percentage change, then we can easily calculate percentage change means new force minus initial force divided by initial force into 100, and we can say percentage change will be 1500%. So by this way we can solve numerical related to Coulomb's law. Now I am discussing next numerical. Now I think very easy to you. Clear? Question number 2. There are two charges. One is 10 microcoulomb and other is minus 10 microcoulomb. There are 2 point charges, and distance between these two charges is 60 centimeter. One charge is placed at point A, other charge is placed at point B. This is diagram related to the question. One is A charge, other is B charge, and distance between their centers or distance between center of mass of the charges is 60 centimeter. And here at the center, this is center O. At the center there is a charge of 1 microcoulomb. At the center there is a charge of 1 microcoulomb. So now I think question is very clear. There are two charges, one is 10 microcoulomb, other is minus 10 microcoulomb, but they are placed at a distance 60 centimeter. They are separated by a distance of 60 centimeter, and we have to find out electrostatic force of interaction at point O, or we can say center. It means this is our question. You have to find out electrostatic force at center. That is our question. Now I think very clear. Question is that there are two charges and you have to find out electrostatic force at the center. Solution. Now I am marking the direction only in this diagram, not going the diagram again. I am marking only here. Solution. This 10 microcoulomb charge will apply a force on this 1 microcoulomb charge, but the direction will be this, or we can say this is FA. Clearly see the direction. This is 10 microcoulomb, this is 1 microcoulomb, both are positive. If we calculate force on 1 microcoulomb due to 10 microcoulomb, that is represented by FA, and it will be in this direction. Similarly, if we see this minus 10 microcoulomb, this minus 10 microcoulomb will attract this charge in this direction. It means the direction of FB is also this. So now from diagram it is very clear that both the vectors are in same direction. Therefore net force at the center will be equals to FA plus F. Both the vectors are in same direction, and if we calculate the magnitude, here it is FA, here it is FE, FB, so this is FC equals to FA plus FB, that is net force at the center. Now if we calculate the value, we can easily see here that FA equals to K Q1, that is 10 into 10 to the power minus 6, and here it is 1 into 10 to the power minus 6. It means simply we can write 10 to the power minus 6 and divide by R. Very clear, this distance is 60, therefore this distance will be only 30, but it is 30 centimeter, therefore we have to write 0.3 whole square. This is the value of FA. Or then you can finally solve 9 into 10 to the power 9, that is the value of K. Here it become 10 to the power minus 12, this is 10 to the power minus 11, and divide by 9 into 10 to the power minus 2. So now we can easily solve it. Here it is 10 to the power minus 2, here it is 10 to the power minus 11, therefore 10 to the power minus 9, and again it is 10 to the power plus 9, therefore it is 1. The value will be 1 Newton. You can check it. K Q1 Q2 by R square. Q1 is 10 microcoulomb, therefore 10 into 10 to the power minus 6. The other charge is 1 microcoulomb, that is also 10 to the power minus 6, and distance between them is 30 centimeter, that is 0.3 whole square. It becomes 10 to the power minus 12, then it is 10 to the power minus 11, here it is 9 into 10 to the power 9, and 0.3 whole square, that is 9 into 10 to the power minus 2. This 9 cancel out by this 9, 10 to the power minus 2, here 10 to the power minus 9, finally it is 1 Newton. Similarly, we can also calculate FB. This is FA, and we can also calculate FB. I am calculating here. FB first. 9 into 10 to the power 9 into Q1, that is again 10 microcoulomb. It means both the charges are same, therefore we need not to calculate, the answer will be exactly same. If you put the value, you can put 10 into 10 to the power minus 6 into 10 to the power minus 6 and divide by 0.3 whole square. It means here magnitude of both the charges is same, therefore force will be also same. We can also directly write 1 Newton, and this is 1. So finally the net force at the center will be 1 plus 1, that is 2 Newton. Along the direction we can say OB. So by this way we can find out electrostatic force at any point. Now question number 3. There are 2 point charges. There are 2 point charges having value 20 microcoulomb each. There are 2 charges having value 20 microcoulomb each, and force between, they are separated by distance r. There are 2 charges, 2 point charges, one is 20 microcoulomb, other is also 20 microcoulomb, and electrostatic force between them is F. This is given. electrostatic force between these two charges is F. It means, what is the question? There are two charges, 20 microcoulomb, 20 microcoulomb. Distance between them is R and electrostatic force is F. What will be new force? If this charge is distributed over two spheres like this. This charge is distributed over two spheres. This distance R is 1 meter. And now the spheres which we are considering are having radius 10 centimeter. So this is also 10 centimeter. They are two identical spheres having radius 10 centimeter. 2 point charges placed at distance R, that is equals to 1 meter, and force between them is F. Now what change have been made? This 20 microcoulomb charge is given to this sphere. This 20 microcoulomb is not just at this point, this is given to this sphere, and 20 microcoulomb is also given to this sphere, like this. So now we can easily see that this is positive charge and this is positive charge. Due to electrostatic interaction, the positive charge redistributed and the whole positive charge given to this sphere reside on this side, and similarly charge given to this sphere accumulate only on this side, and due to this their distribution or the center of mass get changed. In this situation, the center of mass slightly shift in this side and the center of mass of this sphere slightly shift in this side due to accumulation of charges on the opposite sides. And therefore, in this condition, R will increase. In this condition, distance between the center of mass, that I am considering here, distance between center of mass of charges, distance between the center of mass of charges is increasing, and therefore force between them will decrease. So this is high order question, or very important question, that if there are 2 point charges placed at certain distance apart, force between them is F, that is already given. Now the charges are spread uniformly on two spheres, and the radius of spheres are mentioned here. This is 10 centimeter, this is also 10 centimeter. Now due to this repulsive force, here the charges will be repelled. Therefore this positive charge will accumulate on this side, and the positive charge of this sphere accumulate on other side, and therefore their center of mass of charges gets shifted. This is on this side and this is on this side. Therefore distance between their center of masses increases, and that's why force decreases, because force is inversely proportional to distance square. So this is a very important question. I think it is very clear. In this case, the force will decrease because distance between their center of masses is increases in comparison to initial distance. Now I think it's clear. Question number 3. Now we are discussing some more questions related to Coulomb's law. Question number 4. Now we are considering a system of 3 charges so that we can easily understand the concept of principle of superposition. Three charges are placed on vertices of an equilateral triangle. This is equilateral triangle, it means all the angles are equal. This is equilateral triangle, and distance between two vertices, or we can say side of equilateral triangle, is D. There are 3 charges. This point I can mark as A. Let us suppose this point is B, and here is a point charge C. These are the names of these points. At this point, I have considered a charge plus q. At this point, at the vertex A, there is a point charge plus q. At point C, also there is a point charge plus q. At point C, there is a point charge plus q that I am mentioning here. At point C, again there is a point charge plus q. And at point B, there is a point charge minus q. So now I think you are understanding the question very easily. At point A, there is plus q charge. At point B, there is minus q charge. And at point C, there is plus q charge. We have to find out net force acting at point C. What is net force, or we can say resultant force at point C due to these two charges? Now we will draw the diagram. This is plus q charge, this is plus q charge. This charge will repel the charge in this direction. So this is the direction of FA. I am mentioning FA. FA means force on this charge C due to A. So due to A I am mentioning, that is FA. Now this will attract this in this direction. This will be FB. Now we can easily understand this angle will be 120 degree. And we have to find out the resultant of these two forces, and the resultant will be given by the parallelogram law of vector addition. By using parallelogram law of vector addition, we can find out the direction and magnitude of force acting at points. I think it is very clear. We can draw this diagram like this. Then magnitude of electrostatic force and direction will be like this. So I am calculating the value. Here we can say FA. The magnitude of FA will be Q divided by d square. And similarly, it is also the magnitude of FB. It means FA and FB both are equal in magnitude, but their direction is different. They are not along same direction. FA and FB both are having same magnitude, and let us suppose this I am representing by F only. So need not to write K, Q and D square again and again. FA equals to this, equals to FB and equals to F. But these two forces are acting along different direction. They are acting along 120 degree. Therefore, net force F resultant will be equals to root over FA square plus FB square plus 2 FA FB cos 120. And that we can write F square, because FA we have already considered F. FB is also F. So F square plus F square plus 2FF, and now it is cos 120. Cos 120 will be cos 180 minus 60, and the value will become minus half. And if I write minus half here, 2 into 2 and 2 cancel out, it becomes minus F square. Therefore this F square cancel out, and finally we get F only. And this result we can also use directly from class 11. Class 11 से हम जानते हैं, if there are two forces having equal magnitude and they are inclined at 120 degree, then the magnitude of their resultant will be equal to magnitude of either force. It means two charges F और F अगर 120 डिग्री पे है तो उनका नेट रिजल्टेंट फोर्स भी कितना आएगा, F आएगा. Therefore F resultant at this point is F, and we can also mention the direction N. Therefore net force or resultant force will be equals to F Newton, and in which direction? Along Cn. We can also mention the direction, that is F Newton. This is the